Hello everyone, I am Balaji Rao. Welcome to BR Max class. This is 6th class on vector algebra. Till now, we learned theory part related to first exercise and we completed first exercise problems of NCERT textbook exercise number 10.1 from vector algebra. In case if you didn't watch those videos, I'll give that playlist link in cards here. In this class, we are going to learn about addition of vectors. In this addition of vectors only, you will learn triangle law of vector addition and parallelogram law of vector addition. Triangle law of vector addition, parallelogram law of vector addition are very important things which will be useful throughout this vector algebra chapter. Before going to start this video, please drop a like for this video. Without much delay, let's begin the class. In this class, we will learn how to add two vectors. How the addition of vectors is defined that we are going to learn. For that, I will consider two vectors like this. You observe this diagram, I consider two vectors A bar, B bar. Here, I will name the vector A bar as OA bar. I will name like this. If you want, you can keep it as AB bar also. Just for our convenience, I written here A bar as OA bar. And I'll name this B bar as AB bar. Okay, the same thing I written here. Let A bar comma B bar are two vectors such that A bar is OA bar, B bar is AB bar. Now we will learn how to add these two vectors. You may get doubt that if A bar B bar are not like this, then how we add the vectors? Suppose two vectors are like this, A bar B bar. How to add these vectors? You know that in vector algebra chapter, whatever vectors we will consider, they are all free vectors. In case if the vectors are like this, then can we add vectors? Yes, we can add. To add these two vectors, what I will do, this second vector is there, na? Without changing its direction, I will shift this second vector to here. Because we know that these vectors are free vectors. These vectors are independent from its position in space. This B bar, I can shift to here without changing its magnitude and direction. Now further I can add. So what happened here? I consider two vectors A bar, B bar such that OA bar is A bar, AB bar is B bar. Then to define addition of these two vectors, first point, if this is OA bar na, I will consider this as first vector. This is AB bar na, I will consider it as second vector. The terminal point of first vector and initial point of second vector must be same. To add these two vectors, terminal point of first vector, initial point of second vector must be same. So what happened? I consider two vectors A bar, B bar like this. Then addition of vectors A bar comma B bar is denoted by A bar plus B bar. That addition is defined as, listen this carefully. The addition is defined as the directed line segment joining from initial point of a first vector to the terminal point of a second vector. You join them. This is the initial point of first vector. This is the terminal point of second vector. You join them. You observe here how it is defined as directed line segment. Addition of these two vectors is defined as directed line segment joining from where to where? Initial point of first vector. See, this is the initial point of first vector to the terminal point of second vector. So, what is this vector? This vector is A bar plus B bar. Very simple. This is addition of vectors. I'll quickly recall what is the definition of addition of vectors. Let A bar comma B bar are two vectors such that OA bar equal to A bar and AB bar equal to B bar. Here what point you need to understand, the terminal point of first vector, initial point of second vector must be same. Then addition of vectors A bar comma B bar is denoted by A bar plus B bar and it is defined as directed line segment joining from initial point of a first vector to the terminal point of second vector. Whatever I written here in simple words, you look here OA bar plus AB bar. You observe here OA bar plus AB bar. What is addition of these two vectors? You observe the terminal point of first vector, initial point of second vector are same. What is OA bar plus AB bar? OA bar plus AB bar is OB bar, it is a directed line segment joining from initial point of a first vector to the terminal point of second vector. This is very easy only. Here direction plays important role. You observe A bar B bar direction, you observe A bar B bar, A bar B bar direction is like this. Now you observe addition of these two vectors, that means resultant of these two vectors. Resultant of these two vectors is opposite direction of A bar B bar. What is the direction of this vector? It is going like this. This is opposite direction of A bar comma B bar. So this is the definition of addition of vectors. Now we will learn what is triangle law of vector addition. You observe here there is a triangle OAB, right? In this triangle, A bar B bar are the two sides of the triangle. A bar B bar are the two sides of the triangle. You observe their direction. Okay, the resultant of these two vectors is the third side of the triangle, which is opposite direction of A bar comma B bar. If A bar comma B bar are any two sides of a triangle like this, then the resultant of these two vectors A bar plus B bar is the third side of the triangle, which is opposite direction of A bar comma B bar. So I explained this addition in a triangle, that's why this is known as triangle law of vector addition or triangle law of addition of vectors. Simply whatever I written here, this is the definition of addition of vectors, which is same as triangle law of vector addition. Now I'll discuss two very important point which we use very frequently throughout this chapter. You observe here OA bar plus AB bar is OB bar. From this, can I write AB bar? Note 1. From this, what is AB bar? AB bar is, you take OA bar to other side, AB bar is OB bar minus OA bar. In earlier classes, you learned what is OB bar. OB bar is position vector of point B. What is OA bar? OA bar is position vector of point A. Here important thing is AB bar can be written as OB bar minus OA bar. That is important. AB bar can be written as OB bar minus OA bar. This we use very frequently while doing exercise problems. Whenever you see AB bar, if you know OB bar, OA bar, then AB bar can be written as OB bar minus OA bar. Not only AB bar, suppose you saw somewhere BC bar. BC bar is there. The vector BC bar can be written as OC bar. Look here, OC bar minus OB bar. Suppose you want to calculate PQ bar. You know OP bar, OQ bar. Already given that information. Then PQ bar can be written as OQ bar minus OP bar. This is the point we use very frequently. How we got this? This we got from addition of vectors only. Second note point. From addition of vectors, you learn this point. OA bar plus AB bar is OB bar. OA bar plus AB bar is OB bar. If you observe here, terminal point of first vector, initial point of second vector is same. Then addition of these two vectors is the directed line segment joining from initial point of a first vector to the terminal point of a second vector. That is nothing but OB bar. From this also, whenever you see something like this, AB bar plus BC bar, you saw this, AB bar plus BC bar. You see, terminal point of first vector, initial point of second vector, both are same. AB bar plus BC bar can be written as AC bar. This is also point we use very frequently from now onwards. Something you saw like this, BC bar plus CA bar. BC bar plus CA bar can be written as BA bar. How we are writing all these things? We are writing all these things from the definition of addition of vectors. These two note points are very important. Note 3. Commutative law holds good with respect to addition. That means A bar plus B bar is same as B bar plus A bar. A bar plus B bar is same as B bar plus A bar. I'll try to explain why A bar plus B bar is same as B bar plus A bar. You already learned about this addition of vectors. Na? This is the triangle. Now what I'll do, I'll form a parallelogram from this. You observe here, I formed a parallelogram OABC. You suppose this is a parallelogram. Now, what is this vector? We know that in a parallelogram, opposite sides are of same magnitude. What is OC bar? OC bar, AB bar will be of same magnitude and same direction. So this is the vector B bar. And what about this CB bar? CB bar is same as A bar. If this is A bar, this is also A bar because these are equal vectors. Okay. So you observe these vectors OC bar. You observe this OC bar plus CB bar. You learn this now. As per that, OC bar, see here, OC bar plus CB bar. OC bar plus CB bar is what? OC bar plus CB bar is OB bar na, right? OC bar is B bar, CB bar is A bar, B bar plus A bar, B bar plus A bar is OB bar. Actually, what is OB bar? OB bar is, what is OB bar? OB bar is A bar plus B bar, right? Here OC bar is what? OC bar is B bar, CB bar is A bar, OC bar plus CB bar is OB bar. That means B bar plus A bar. You observe this B bar, A bar in this direction. Na? This vector is opposite direction of these two. Na? This is B bar plus A bar. This tells you that A bar plus B bar is same as B bar plus A bar. Please think little bit. You can understand this very easily. So what is the third note? Commutative law holds good with respect to addition of vectors. With respect to vector addition, associative law also holds good. A bar plus B bar plus C bar is same as A bar plus B bar plus C bar. Okay. And identity law also exists. That means A bar plus 0 bar 0 equal to 0 bar plus A bar equal to A bar. So what you learned till now? You learned what is addition of vectors and you learned what is triangle law of vector addition. Now we will learn what is parallelogram law of vector addition or parallelogram law of addition of vectors. To explain what is parallelogram law of vector addition, I consider two vectors A bar comma B bar are two vectors such that OA bar equal to A bar, AB bar equal to B bar. This is like as usual how we taken the vectors in addition of vectors. In the same way, I taken OA bar as A bar, AB bar as B bar. I consider two vectors like this. Now you can observe 3 points are there, OAB. Now what I'll do, I'll form a parallelogram OABC with the help of these two vectors. You observe here, I drawn a parallelogram OABC. You know that if OA bar equal to A bar, AB bar equal to B bar, you know that what is OB bar. What is this OB bar? OB bar is addition of these two vectors. OB bar is A bar plus B bar. What is OB bar? OB bar is A bar plus B bar. You keep this in your mind. OB bar is diagonal of this parallelogram. Okay. You observe the vectors AB bar and OC bar. As it is a parallelogram, these two will have of same magnitude. And what about their direction? AB bar is in this direction. OC bar is in this direction. AB bar, OC bar are equal vectors. The vectors AB bar, OC bar clearly equal vectors. Equal vectors means AB bar is B bar na, OC bar also B bar. What is this OB bar? OB bar is A bar plus B bar. Here what you need to know, what is parallelogram law? You observe OA bar, OC bar. OA bar, OC bar. They are the adjacent sides of a parallelogram with the same initial point. What is this OB bar? This is the diagonal with the same initial point. Something we are getting a point here. In a parallelogram, if A bar comma B bar are the adjacent sides of a parallelogram with the same initial point, then A bar plus B bar is one of its diagonal with the same initial point. This is parallelogram law of vector addition. You need to catch this point. Listen this carefully. Here A bar comma B bar are the adjacent sides of a parallelogram with same initial point. When we add these two, A bar plus B bar is the diagonal of that parallelogram with the same initial point. This is known as parallelogram law of vector addition. So here I'll write the same point. You observe OA bar comma OC bar, OA bar comma OC bar are the adjacent sides of a parallelogram with same initial point. Then OA bar plus OC bar, that means addition of these two vectors. OA bar plus OC bar is the diagonal of the parallelogram with the same initial point. That is important. This is important, with the same initial point. If we add OA bar plus OC bar, you will get OB bar. So what is parallelogram law of vector addition? If A bar comma B bar are the adjacent sides of a parallelogram with the same initial point, then addition of those two vectors is the diagonal of the parallelogram with the same initial point. This is known as parallelogram law of vector addition. Now I will discuss one point related to parallelogram law of vector addition. With that you will get more clarity on parallelogram law of vector addition. As per the parallelogram law, we can say this point also. AB bar, AO bar are the adjacent sides of a parallelogram with same initial points. AB bar plus AO bar are the adjacent sides of a parallelogram with same initial point A. Addition of these two vectors will gives you what as per parallelogram law of vector addition? AB bar plus AO bar will gives you the diagonal of parallelogram with same initial point. That means you will get AC bar as per the definition of parallelogram law. Parallelogram law says that there are two adjacent sides of a parallelogram with same initial point. Addition of those two vectors will gives the diagonal of that parallelogram with the same initial point. It is very simple. I hope you are understanding. I hope you understand this. In this class, we learn addition of vectors. In addition of vectors, we learn about triangle law of vector addition and we learn about parallelogram law of vector addition. I hope you understand this class. If you like this video, please drop a like and share this video with your friends so that they'll also will get benefit. In case if you are not yet subscribed to my channel, subscribe now. Thanks for watching. Take care. Bye-bye.